as we've had with the rest of the session, this is going to be about the user experience with analysis tools in CMS. So I think I might take a little bit of a different tack, because I'm gonna talk more about what we're doing in this analysis tools task force, which I'm one of the co-chairs of, and this was a body charged with figuring out what we had done for the past 10 years in analysis and asking people what they've been doing, and also to try to impedance match that with what people are trying to do in spaces like IRIS-HEP and what people are coming up with on their own in CMS as well, how this matches with our current data model that includes nano AOD and mini AOD, which of course has intersections with service X and things like that. And then also to figure out how to make things, what we can do to make things more efficient, and come up with recommendations for how to guide the collaboration towards doing that. And you can see all the charges and stuff here. And if you have access to CMS DocDB, you can go and see the full charge and everything else we've produced. But I think the first and most important thing that we've done so far is actually try to understand how people have worked in the past and what that user experience was, and then that gives us really good context for how things should look in the future, and where to actually work on providing better options than what we have had in the past. I'm not going to talk a lot about coffee in this presentation, because everyone's had an earful of it for the past day and a half. And I think we get the point there. So this is really more about where we've gone, and trying to think about where we're going, at least within CMS. So what we found with respect to what were the most common analysis patterns in CMS after actually collecting polls and interviewing people and having authors of frameworks come by and talk to us, is that you'll start from, actually it's kind of 50-50 split between nano AOD and mini AOD, but we still have people going back to heavier data tiers, like AOD in the case of long lived particle analysis, or analyses that need very detailed detector information like WMAS. And then they produce some sort of post-process n-tuple, even from nano AOD, which I think in this crowd, people are going to find that a little bit funny. But oftentimes what happens is that you produce a whole new nano AOD with a few extra columns, and then you do your analysis processing from that. People are usually doing like jet reclustering, or some sort of, some sort of neural network inference that they're tacking on to the nano AOD, so they don't have to reprocess it all the time. And of course, we know from all the tools that we're developing in IRIS-HEP that picture is drastically changing. So this kind of workflow pattern starts to make less and less sense. Usually people are using CRAB or their local batch systems in order to, CRAB for the grid or their local batch system, and their turnaround time is somewhere on the order of days to weeks, depending on how they've set things up and how many data sets they need to process. And then once they have this sort of nano AOD or nano AOD equivalent n-tuple that they run their analysis on, that's when they actually run their data reduction frameworks. And we found that these had a really wide range of scope, from just simple root macros all the way up to fully fledged analysis frameworks, sometimes even running inside of CMSSW, producing their final n-tuples. And this tended to have the processing time of hours to days. And then finally, of course, the key to it all is, in terms of getting actual physics output, is CMS's combine framework, which is the fitting tool that we have in CMS that came out of the Higgs group, and now we use throughout the collaboration as kind of our common language and common repository of statistics knowledge and capability. So getting on to more numbers. So I said we predominantly saw those 3 data tiers. Here you can see how they're spread out. You can still see that there's a lot of people starting from mini AOD and making their own n-tuples, whereas, what is it, about a third of the collaboration now is using nano AOD, which is actually more than we expected. I mean, you can add up and see the statistics here in judge for yourself exactly how accurate this is. But you've still got some hint of people using the older data tiers where essentially most of the collaboration is still running their own intupling, but we're starting to get more and more adoption of nano AOD, especially as we make it more inclusive and more flexible over time. There are often people now producing their own private nano AODs with custom editions and things like that. And I'm not going to talk about the rest of the recommendations that we're making within CMS fully, but one of the things that we are recommending to CMS is that instead of people just making their own intupler again, that people use nano AOD as a common format. And even if it is not centrally managed, you're getting people to the idea of thinking in flat, or of objects splayed out into flat trees, which is generally the most efficient data format that you can have for a final analysis in tuple, just because the transport properties of that data are about as fast as you can get them. So once people have that, what do they do for it for post-processing? How do they get their analysis done at the end of the day? We asked people if they use CRAB, if they post-process. The answer to post-processing, as you can imagine, is almost everyone post-processes their data in order to get it down to something that they can iterate quickly on. Because we know that as you go through an analysis, your time to insight or any sort of time to reiteration becomes necessarily shorter and shorter as you get down to the end of the analysis, basically. And sometimes you have one that goes for a while, that someone asked a really annoying question in your review team and you have to redo everything. But most of the time it's people answering questions quickly or trying to answer those questions quickly. And so time is really of the essence. So post-processing is a big thing. And one of the big impedance mismatches we found in that is that if you really needed to get something done quickly and there was a deep question to ask, you could very often just, you wouldn't be able to do that. You just have to wait because you need to thunk back to the grid or something on that order of complexity. As far as data reduction, you can see that the collaboration is starting to adopt the new tools from these pie charts here. But most of what we did for run 2 was heavily based on kind of traditional, T-tree make class kind of frameworks. With various bells and whistles of different types added on. But we're starting to get fairly solid uptake of some of the Python Python ecosystem tools in our data frame, including PyR data frame. And you can see the breakdown of that by brand name in the pie chart on the right. So you can see coffee, there's TreeMaker, things built on top of coffee, and FastHEP. There's Bamboo, which is written on top of our data frame, and various flavors of the CMG tools, the CERN group tools as well. And then there's a common framework called Nano AOD tools, which is actually PyRoot based, that most people use just because it's really easy to use. But people also recognize that it's fairly slow. It takes them a long time to reprocess what they're doing. And that drives the need for what's going on in the what's going on with uptake in the Python ecosystem and for our data frame. Moving onwards, because I know I'm running out of time and we would like to have some discussion. The thing where we actually had some of the most interesting discussion, let's say, was getting to our statistical tools. And I saw that did come up in the Atlas talks and in the LHCb talks as well. In the case of CMS, Combine is sort of so organically managed, if you can think about that for a second, that there is no replacement to it because of the depth of features that it has and the types of models that we build up with it, and kind of the common language that we've created with these combined data cards, even though it's not formally defined. So there's that, and the fact that we've built it up since the times of the Higgs, and people just haven't taken time to take it apart and rebuild it. We have now this huge interface that we need to fulfill, which makes it hard to do that. The other interesting thing that Combine does is, because it's been like where people have learned and programmed statistics at the same time, it's actually an excellent textbook. Using Combine is, it puts Combine in this weird place of being a tool as well as a implement for learning and pedagogy otherwise. So what we're going to do with that to try to angle ourselves towards the future whilst keeping the interface that we have so far, which we've found to be highly effective, is we're going to try to formalize things and define what the interfaces inside of Combine actually are, so that we know what we want when we're moving to these new tools. Because I think people have actually made Combine to PyHF converters, but PyHF has only a subset of the things that Combine can do, and people like having their freedom and don't really like being told what to do or being put inside of a box. So that's where the impedance mismatch with like CMS and PyHF comes from. It's not any particular ire or anything like that. It's just, people want to do the analysis the way they want to do it. So yeah, in order to facilitate that, we're going to actually write down what our interface is so we know what we need to fulfill. We're going to be thinking towards speed optimizations, like trying to use auto differentiation once we've defined what the full set of functionalities are that we want, or maybe we can define a subset where we can use the auto differentiation. There's a bunch of creature comforts and things like that we would like to do as well. One of the interesting things that came out of all of this, and I think may have been spurred on by PyHF into its current implementation, although it needs to be refined, is the fact that RuFit is now looking heavily into defining statistics model serialization and trying to turn that into something that can be into something where you can take take a model that you've built in RuFit and write it out as JSON, and at least that starts to standardize an interface in some sort of reasonable way. So we're going to support that and try to work out something higher level that we can agree on with within the CMS collaboration, so that we're not stuck to this tool forever, but rather we're stuck to an interface and a set of things that we would like to do with tools. Going on to what we've been talking about largely in this workshop for the past couple of days, the data reduction tools. So, I'll keep this one quick. We're looking forward. What we're looking forward to here is really trying to understand how people are using things like Coffee and PyRDF now, and what's already been done by folks who have been spending lots of time thinking about how the future should look and aggregating that together, so that we don't get the usual 1,000 flowers bloom and then people copying other people's flowers and things like that, but instead make it so that we know what our foundational libraries are in CMS for starting up an analysis. And one thing that we're gonna be recommending at the end of the day is that we take that we have a complete example of an analysis with systematics, et cetera, starting all the way from data ingestion, going through to the final combine fit and getting the output numbers, so that people know how to use all the pieces and parts that have been developed and how to put it together into a coherent whole. One thing that we've been stressing throughout that, and that I know Jim and the root team and folks like that have been working on, is making sure that everything is interoperable. And I think that's starting to shape up quite well. And if we can do that, then anyone can work together in whatever configuration they would like, and that makes us much more efficient at being physicists working together at the end of the day. So I think everyone's had some sort of interface with our data frame at this point, and they understand the kind of I lost the word. Yeah, that's what it is. The declarative analysis mode that they're trying to go for. One of the interesting things that we found that we've been talking about recently, because it's one of the more thorny things in analysis, is actually the vary function and the handling of systematics in general. And the fact that this is being handled at such a low level is actually really interesting and good for us. It forces us to come up with good implementations of such things elsewhere, like in coffee. And we've got a prototype, but it's not entirely there yet. So, right, I think everyone's had a thorough introduction to coffee and what it looks like, and or what we're going for with the Python ecosystem tools there. So far within CMS, as you saw from the pie chart earlier, we do have people using RDF and coffee directly. All of these starting from around 2019 in various stages of maturity. And you can see all the different implementations of full analysis frameworks starting off from RDF or coffee. And you can follow some of the links if you would like to. And on CMS, we're also trying to promote the adoption of the analysis facilities, which we had some nice presentations on over the course of the last 2 days. And I think I can actually skip through this because most of you have seen it. The main thing to note is the fact that we have a number of different analysis facility efforts within CMS that are pursuing different modalities of implementing one of these things. So you've heard at length about Coffee Casa. There's also an analysis facility at INFN that's actually supposed to be countrywide that allows you to get access to a specific cluster and then launch a DAS cluster within that instead of kind of being embedded in the cluster like Coffee Casa is. It's just a different way of figuring it out. There's also the elastic analysis facility at Fermilab, which is a implementation kind of similar to Coffee Casa, except that we have to service multiple experiments when we're implementing this. And we're also looking at effective use of GPUs, and trying to, and we just got recently the scale out onto the LPC batch system within all the constraints of Fermilab computing security as well. Thank you, Bert and Maria. And so that's yet another take on what an analysis facility should look like, especially when you start considering what these things look like when they have to interact with multiple experiments. So there's different constraints or different external constraints on the problem. And then CMAT, MIT, and Purdue are also working on their own facilities prototypes, but they're in a bit of an earlier stage. So far, what we found is since people are choosing Dask or Spark or other fairly common execution engines to run in their analysis facilities, that we've had no problem getting our data frame and Coffee working on these analysis facilities. So we're actually building facilities that anyone can use and hopefully promoting a whole point of interoperability. And yeah, these things generally make our lives easier and hide a lot of the complexity that's usually inherent in an analysis. One thing that comes up very, very often that people complain about quite consistently is the handling of errors in these execution engines. Dask is a little bit more clear than Spark because there's not the infinite Java exception output you get from Spark. But at the end of the day, it's still kind of hard to figure out what went wrong and how. And knowing that, especially for a physicist, is really important. And I think if we want to get to the fullest level of maturity where we're actually really understanding what's going on and can control the system in the case of failures, which will happen, we probably need to talk with the authors of Dask and Spark and WorkQ to make this simpler and more straightforward. So that's my one soapbox moment. And so I'll take us to the concluding remarks, which are, I would say that the user experience of people doing data science and physics in CMS is really changing rapidly. We're right in the middle of a transition from old style root analyses and using PyRoot and stuff like that to using things that are wildly different like Coffee, or maybe slightly more similar like RDF, but there's still quite a change as compared to the way you're usually, we teach people for the most part right now to interact with their data when they're onboarded as a grad student. Although that is also changing because we have workshops like this. I guess that just goes to show exactly how dynamic all of this is. But all of this is really being led by some intrepid early adopters and people kind of pushing the ideas. So I think we're doing a good job there. And I would say that coffee and RDF are actually being kind of explored equally by the community, and anything to further support interoperability and make it so that in order to get things done, it doesn't matter what you're using, is something that we should focus on. So that's it for me. Thank you.
Thank you very much, Lindsey. Sorry to be like having you give the talk under these circumstances. Thanks a lot for joining us, regardless, and giving us very valuable
that's
perspective.
my fault for scheduling things poorly. Yeah, the life's just a mess right now, man.
Okay, so let's do the following. Let's start with quick questions that we might have specifically to CMS, and then we'll go into a more general discussion. While I'm talking, I want to point out one thing. If you're interested in this workshop and connected right now, there's a good chance you're also going to be connected in a workshop happening 1 month from now. I'm pasting the Indico agenda in the Zoom chat right now, which is the HSF Analysis Ecosystem Workshop happening in Paris in person. So check that out if you're not aware of it yet. And let's see, do we have any specific questions for CMS here, for the CMS contribution from Lindsey?
Oh yeah, and thanks to Nick Manganelli and Melo for taking care of the chat box. I see it's been lively.